Welcome back, nerds. Today we are going to talk about our proofs, and I just want to make sure that this is recorded somewhere if you're struggling with it. For the record, nerds is a term of endearment for me. It's a compliment, not an insult, first and foremost. Second of all, I don't know any of you well enough to really say confidently that you are a nerd. I know that I am. You guys are just geometers for now. Maybe someday you'll reach that level of nerd, but we'll see. Okay, so whenever we do proof, we always do two column. Now, we're never going to write this all again, but we have one column that's the given statements and one column that is our logical statement or what do we know from this statement. So right off the bat, I don't care which angle pair we work with. We don't have to do both. Do you want to assume that 1 and 3 are vertical or that 2 and 4 are vertical? Okay, so check it out. Every book does this a little bit differently. I'm going to have, you don't have to write this every time, so pink, I just want it here. We have our statement, and we'll always have a statement on the left, and we will always have the reasoning on the right. And I'm going to close that door, otherwise we're going to hear grinding metal for the next hour. Okay, we write a mathematical statement and a reason. Now to keep track of stuff, because each time we write a statement, we need to be able to justify it or reason behind it. I use letters. And what I mean by that is I use statement A and reason A. And what I would suggest, and it gets annoying if not, if we're just looking at it, if I have A, and then B and B, and C and C, do you guys agree that that's kind of annoying? Okay, when I write it, and I know that everybody's gonna have different styles, I will try very hard to make this reason, line B, line up with the other one. Otherwise, it can be hard to make sense of what's going on. So, let's check it. Our first statement, every proof ever, is going to be our givens. What is the hypothesis that we're allowed to assume is true here? So angles are vertical, and I even let you guys go a step further. For statement A, which vertical or which angles did we say are vertical? I'm okay with that. Angle 2 and angle 4 are vertical. We have to make sure that our hypothesis is written somewhere. Could I have done 1 and 3 instead?
Yes.
For sure. Okay. This one, every time our proof will start the same. Like obviously a different statement, but all we need here is given. Now it might be multiple, so we could say givens, but I don't know grammatically whether or not that really works. I call it given. Okay, there's our given statement. And we're going to rely on a bit of your old geometry stuff that you hopefully, and if not, I'll remind you, but I think it's stuff you've seen before. Okay, we are trying to end up where? What's the conclusion that we're after? If angles are vertical, which these are, then the very last line of my proof should claim what as my conclusion? Be more specific. If I start with angles 2 and 4 are vertical, my very last line should say that angles 2 and 4 are congruent. Okay, so we just have to logic through this. The picture helps because we can draw with it. I'm going to just kind of work us in here. If two angles are congruent, that means that their measures are equal. Do you guys agree with that statement? Now, for now, we don't have a bunch of theorems that we can use to justify stuff, but we do have some postulates that we can use. So I'm going to look at this, and I want you guys, I'll help with the statements, especially for now, but I want you guys to help me come up with the justifications. I'm going to make the following claim. If I were to take the sum, and we're doing 2 and 4, if I took the measure of angle 2 plus the measure of angle 1, and we're going to introduce some new vocab in here rather than just laying it all out separately. I think we can do it here. Can anybody tell me your gut feeling, if you were to add up these two angles, what do they add up to? Ray thinks 180. Does anybody agree with Ray? A straight line is always how many degrees? 180. Now, we have a pair of angles that form a line, right? We have fancy language. I'm going to sneak it in here rather than making it like a formal definition. But I agree with you. I think that this is 180 degrees. And as soon as we write our statement, we have to justify it. I'm going to justify this with the following language. I'm going to sneak it into the vocab. I have a pair of angles that form a line. Everybody agree with that? I'm going to sneak in our vocab, linear pair. Do we have a pair of angles that form a straight line? Boom. There's our linear pair. Now, here's where stuff works out and where if you're going to make your arrangement look goofy, it's going to happen right now. Some books and some teachers would have you write statement C. When I'm looking at how is this proof actually going to work, my goal is I need to get eventually, I have measure 2 in here. I need to get a way to get measure of angle 4 in here as well. And I need to show that they're equal. Because if their measures are equal, then the angles are congruent. Like that's our route through the problem. Does that click with you guys? We need the measures to be equal at some point, and then the next line will say they're congruent, because that's what it means. That's the definition of congruence. So, some teachers, some books will say step C. I have measure of angle 2 in my proof already. Oh, my belt loop is caught on that. I'm going to bring a spare pair of pants, because I have spare shirts, but I can just imagine the day where I've ripped my pants and I don't have a pair here. Okay. Can we write another statement anywhere to get measure of angle 4 into this logical construction? And it's weird at first, but check it out. What can I add to the measure of angle 4 to use linear pair again? Is there another linear pair that includes angle 4? We could do 3 and 4. If I wrote these, what do they add up to? Is that the only linear pair we could do? Could I do 1 and 4? Is one better than the other, do you think? I think so. Now, you might not see logically why that's the case, but I'm going to write it with 1 and 4. So, here's what I would recommend. I don't want to call this line C. If I make the claim that measure of angle 1 plus the measure of angle 4 is 180, what would my justification be? Linear pair. Is that the justification I just used? So if I don't want to, and I'm okay with not doing it, if I'm going to use the exact same justification for a different statement, I don't start a new letter. I just keep it here. Measure of angle 4 plus the measure of angle 1 is also equal to 180 degrees. Notice, if I don't put a new letter, it is this same justification. If you want to, I will never do this, but you can. You could call this line C, and you could justify C here and say, once again, it's a linear pair. But does anybody else feel like that's kind of redundant? Me too. I don't like to do it. I'm not going to do it. If you want to, you can. All right. Here's the tricky part. Do you guys remember any properties from algebra about stuff? Like, if I said, and this is going to feel, this first one's going to be clunky, okay, because we're going to get practical. If I told you that the following, let's say x equals 7, and I want you to find 2x plus 3. Could you guys do this? Everybody get 17. Or
I mean, I didn't solve it, but.
Okay, do you see how I got 17?
Yes.
What did I do?
Put 7 in the x.
I plugged it in, right? I substituted it. Are you guys okay with that? So check this out. Up on the board right now, my goal in the end, remember, is to get to measure of 2 equals 4, and then I'll say they're congruent. I know that this is one way to write 180. Is there another way that we say, hey, look, 180 is still 180? I know that here's another way you could write 180, right? 4 plus 1. Now, if we want to be super duper formal, which we can, I would not normally include this step, but I think it's worth seeing. Do you guys remember what the reflexive property is? What? Kind of? Okay. So I don't necessarily like the idea of just reflecting ray, but because it's not reflective, it's the reflexive. Okay, this one feels stupid. What is 180 degrees equal to? Guaranteed. There's several answers.
2.
So you could do it here. Good, I agree. Don't do it yet. You could do this, right? This is going to feel dumb. Is this true? Okay. Now, we wouldn't normally include this, but we're going to see why we might. Because I think it's reasonable that we could skip this one. I just used the reflexive property. Something is always equal to itself. Now, I would normally elect to skip it, but I want you guys to see, like, look, this property does show up. We don't normally have to write it, but sometimes we will. Here's what I'm going to do. Give me one way based on the board to write 180. So 1 plus 4. Do you guys agree with that? I'm going to substitute for this 180 degrees, and I'll underline on mine so it's clear. This 180, I can write like this. Cool. So here we go. We know then that the measure of angle 1 plus the measure of angle 4 is equal to 180. But I'm not going to write equals 180 yet because we already have that. Is there something that I could write 180 with a different way? Ray notices that the measure of angle 2 plus the measure of angle 1 could replace this 180. Do you guys agree that if it's 180, I could just plug it in? So let's do that. I also have that the measure of angle 2 plus the measure of angle 1 is the same thing. How did I do that? You said plug in. I used a different word. We used substitution. If we know something is equal, we can substitute. Okay, here's Holloway shorthand. We have, if I just write sub, it's not clear because I know that substitution starts with sub. Can you guys think of another math word? Subtraction. So here's what I do. Subst. If you want to write substitution, I'm good with it, and I will write it this time. I have no issue as long as, like, even without discussing it, if you shorthand something and it's you think reasonable that you and I would come to the same conclusion, I'm good with it. Okay, don't just use subs is what I would use here. Anybody's proof sense is tingling yet? We need to get to their congruent in the end, right? But before I can say they're congruent, we have to say that they're equal. Back to that algebra question. If we have an equation, which we do, this is very much an equation, can I subtract the same thing from both sides? That's called the subtractive property of equality. I'm just going to call it subtraction. If things are equal, we can subtract from both sides. We can multiply something on both sides. We can divide. All those are just properties of equality. Any suggestions on what I subtract from each side here? If I subtract the measure of angle 1 from the left and the right side, what would remain? Andrew, make sure your eyes are up here, okay? Because this is like, we're going to use this for literally the next 8 months. If I take this away from each side, measure of angle 1, don't cross it out on yours. I'm just doing it to make it easier. If we subtract that from both sides, what does my equation now read? The measure of angle 4 is equal to the measure of angle 2. Now, we don't have to specify here. I'm just going to say subtraction, which notice, here's the shorthand that I would use. That way we know that substitution and subtraction are different. Have we gotten to exactly what the then statement is? Have we? We want to show that they are congruent. Right now we have that they are equal. Are we almost there?
Yes.
We have one more step. If angles have the same measure, then we say that by the definition of what it means to be congruent, that those angles are what? If the measures are equal, the angles are, check it out. Angle 4, guaranteed, is congruent to angle 2. And this one, I'm going to write my shorthand on the board, and I want to see if you guys can reason out what it is. If I write this, what does that read with real words?
Definitely congruent.
Definitely is a good thought, but it's not quite what I'm after. It has to end with an N, because that's how my contractions work. Ooh, you're so much closer. This is literally the definition of congruent. Now, this logic that we just used, super hard to think through. Were you able to follow? Like, everybody's going to be at a different spot. Thumbs up says, man, that was way easier than I thought proof was going to be. Thumbs down says, oh my God, I hate it so much. I wish it would die. Anywhere in between. Okay, so we have 1 or 2 people who really hate them. We're okay with that. Here's the last fun thing. You guys get to learn a little bit of Latin. When you write a proof, there's always one of two things you have to do at the end. Whoever's reading it has to know that the proof is finished. Now, obviously, we know it's finished because we just got from the hypothesis to the conclusion. 2 ways you can denote this. My preferred method is to use this symbol. It's a square that's filled in at the end. This is not a Holloway thing. This is an everywhere thing. This indicates that we are at the end of our proof. We're done. We're finished. You can, sorry?
It's a big period.
It's like a big period, yep. except I'd say it's a square instead. But the alternative we can use, and this you won't normally see me do, but pretty common that you will see these three letters, Q, E, D. Okay. One of these two. This right here is Latin, and everybody knows, obviously, that this is Latin for quod erat demonstrandum. Okay, obviously nobody in here speaks Latin. Quod erat demonstrandum literally means that which was to be demonstrated. Cool. Super challenging. Like, it might not be super easy, but I think you've probably done harder things in your life. Okay, it will take practice. I want to stress, some of you guys will feel really good with this in the next week or two, and you'll be like golden for the whole year. Some of you won't understand proof and really be able to write a good, correct proof until April. Some of you won't be able to by the end of the year. But we're going to practice all year long. We're going to try. Everybody will click somewhere different. For now, we're going to go outside in about 3 minutes. We are going to do a quick Feelings Friday. I've been outside. It looks beautiful, but I bet it's kind of cold. Like, at least chilly. Okay. We want 3 questions outside. I'm going to pick the last one. We'll do our Feelings Friday. I'm going to write them on a whiteboard so we can take them. Ashley asked if we're going to have homework, and she emailed me last night saying, gosh, Mr. Holloway, please give us more homework than you have been. I wish we could do more. I don't have enough to do at home. I want all of us to have more practice.